we have a result. Okay, we're back. Let's get my pens ready. We are doing 4.5 today. Oh my, no sweat today. This will make presentation go a whole lot easier. I'm sure he'll show up just to fix that. Hi, Josue, if you're watching this later. Thanks for not coming. I just have one question to ask. My goddamn lie, Josue. I know you're going to ask me more than one question. Don't trick me. He's not here yet. I need to quit saying his name. It's like Beetlejuice. Fucking show up. So exponential and logarithmic equations. We've done a lot with these in this chapter. Learned about them and shit like that. Now it's time to start utilizing them. I'm going to say you may not use it a lot this semester, but if we have x and y greater than 0 and a greater than 0, where a does not equal 1, then if x equals y, then log a of x equals log t, or a of y.
Oh, wait.
He's looking for the pencil sharpener in there.
Yeah, it was.
Fucking knew it.
Yeah. No, I'll get it. Oh, this? Yeah, I'll get this.
It's fucking embarrassing.
Listen, man. Too lazy, all right?
He doesn't like pride asking for this every, like, it's daily. It's not even just once a week. It's not once 2 weeks. It's daily. Okay. You're probably going to have to ask again before the end of the fucking.
Daily's every day. This is every 5 days.
Only because the classes are spaced like that.
Yeah.
You do with other people in other classes?
No, because I use massive amount of that. Like.
All right, so that's a rule that holds. So like you can use, so where would you use this? You can use this when logarithmic when log properties are helpful. For simplifying work. I mean, we will do some of it here now, but it shows up even better like in later classes. So for example, let's solve 8x equals 21. This is some number greater than 0, and 21 is definitely greater than 0. So we can apply the property here. We can use whatever log base that we'd like. A useful property here, or useful thing with the logarithm basis is if I have this and I choose my base to be the same as the inside, things get easier. Remember, when we have it, exponents can come down. So I have log base 8 of 8 equals log base 8 of 21. This is actually probably the slower way to get to it. But it's definitely accurate. Anything to this base and the argument is the same as 1. So this is x equals log base 8 of 21. We want to find its value. We can switch to bases that we have on our calculator, either log base 10 or log base e. This will just be the log button, and this is the ln button. But we'll do log 21 over log 8. And if you throw that in a calculator, you should get about 1.464. Yeah, Trey. Let's talk about you earlier. He's here.
Yeah.
He did show up. I know, he wasn't here right away, so he was a couple minutes later. Another way we could have just done that when we were deciding the base, back to this line, but before I picked the base. I could have just used base 10 directly from the get-go. If I choose base 10 directly from the get-go, x still comes down. I have x times log 8 equals log 21. And if I divide by log 8, I still get that same thing that we would have done with the change of base formula.
On base 10?
Yeah, when no base is listed,
It's 10.
yeah. It's called the common base.
Sorry, you can go a little bit up. There we go. Thank you.
Uh-huh. You don't know why you're taking notes, Jimmy. Put that shit down.
I was. Wanting to look text.
Just fucking with you, you do whatever you want. I don't know why I even said it. Just being a dick, apparently. Not enough people to be a dick to.
Calling me out.
Eric brought me candy, so I didn't feel like being a dick to him. He also told me his wife's enslaving him tomorrow.
That's
Not nice.
Cleaning the house.
nice. That's on it.
Like baseboards. Like treating it like it's fucking spring. Spring cleaning and shit.
I got married though.
That ain't a get married thing. I haven't ever had to clean baseboards. I've been married for almost 20 years. Be 20 years in April, and I've never cleaned a goddamn baseboard since I got married. Oh,
For heavens.
that's fucking.
Oh yeah, I think we're. That's right. Yeah, I see.
Yeah, but no one looks at the fucking baseboards. Unless you, I don't know,
You don't know.
the children been fucking writing on them in crayon or some shit. I don't know.
Well, actually, you know what? We got them baseboard, hoverboards. So they,
Really?
yeah. So
Do they actually hover?
no, you know they're those.
Like the
They have
Segways?
wheels, they have wheels and they stand on them and they go.
It's the Segway things. Okay.
Yeah. But they've been hitting the walls on the corners. So.
Nice.
Oh yeah, then you make them clean it.
Yeah.
Little bastards. Or even keep. You all right, Luis? Look like you got a headache.
No,
You good? Okay.
looks frustrated.
You know what? I've thought this for a while. I don't think I've ever said it. He looks like a young Lionel Richie. Same hair.
Richie
Lionel Richie.
He's a singer.
Yeah, Richie, what's this called, Van?
No, not Richie.
No, Richie, no, Lionel.
Lionel Richie.
I don't know which that is.
No,
Hello, is it me you're looking
Oh,
for?
really, that's it? I know him by that song.
I thought you might know that's one of his more popular ones.
Yeah, one of those.
Got to see him live, it was really good.
Nice. How long ago?
I was younger than you are. Oh, that's kind of been a while. I was like 19 or 20. I didn't pay for it either. It was the American Music Corps or something like that. I was in Los Angeles and they were letting a bunch of students go for free.
Just happened to be there.
And so I'm like, I want to go do that. Signed up, got in.
Nice.
He wasn't there was lots of singers there, but I really liked that song. Crazy. I've done a lot of things in my life. Grateful Dead, sober. Which is, yeah. I might have been, me and the people I were with might have been the only sober people in the entire Grateful Dead concert. And that's just because we didn't go with the people that had the stash. We took separate cars and we didn't find them. I'm gonna have to edit that later on.
Yeah.
No, this is when I was like 18. I was young and stupid. All right, next example. Let's kick it up a notch. Let's go to the thousands place.
The X plus 1.
8x plus 1, yes. So what we're going to do is we're going to take the logarithm of both sides. I used log base 10 last time. I'm going to use log base e this time. So log base e is ln. I'm going to take the natural log of both sides. ln stands for natural log. When I do that, I can bring the exponents down. I have 2x minus 3 times the natural log of 5 equals x plus 1 times the natural log of 8. Iced peppermint mocha because I'm a dumb shit. It's fucking delicious. It's got fucking caffeine. And I'm gonna have a hard time going to sleep tonight, despite having fucking classes from 8 to 12 in the morning.
I was gonna say, I thought you don't drink that. It's like,
And a wild hair up my ass. It fucking was not listening to my brain. All right, so we need to solve for x here. And so while it may not seem intuitive, and it's definitely not going to be pleasant, we need to distribute the natural log to each thing inside. So I'm going to have, for the ln of 5 and the 2x, I'm going to put the ln of 5 up front with the 2 because it's a whole number. And I'm going to do that to make sure that I know the natural log is just at 5.
21.
That is an L.
Yeah.
It's not a 21. Minus 3 natural. Fucking with me. God damn it.
Started.
Yeah, but I can finish it. That's right. That's fight words right there. He said, bring that shit, son. Bring it. It does look like 21, doesn't it?
Yeah.
How about let's do this? Let's put 2 dot ln of 5 for multiplying. They very much look like 21 and 5. And I don't want that. The other option you have is you can make your L's look a little curly, like cursive L. Have it. Did you learn how to write cursive, Luis? Do they teach this in high? They don't teach this in high school anymore. Or elementary school. You did?
In our yeah, they're teaching us, but then that's when COVID hit.
I heard they didn't teach it anymore.
They teach that again.
In the elementary school,
I heard they don't, at least in some schools locally, they don't teach cursive anymore. It's considered an unuseful thing. People don't write letters anymore. We send emails. I still write cursive.
Yeah, I do too.
Now I know it's fucking secret code against kids. You write messages to your wife and they'll never fucking translate it. It's fucking good shit. All right, so we got X's. These are the things we want to get together on one side. So I'm going to subtract natural log of 8 times x from both sides. And maybe I'll add the 3 natural log of 5 to the other. I'm going to do the cursive L. 3 natural log of 5 to the other side. If I do this, screen pin's dead. I have 2 natural log of 5x minus 3, minus natural log of 8x. And then on the right side, I have natural log of 8 plus 3 natural log of 5. Believe it or not, this is just a number. It's just a number. It's a value. So what I want to do at this point is factor out the x. If I do, I have x times 2 natural log of 5 minus natural log of 8 equals natural log of 8 plus 3 times the natural log of 5. I need to email Snickers and let them know to do a cherry version. Shit was fucking great.
It's crazy.
I really like chocolate cherry.
What about chocolate strawberry?
Chocolate strawberry is good, but chocolate cherry is way better. In fact, Target used to sell a coffee from Archer Farms, and they had chocolate cherry and chocolate strawberry. And my wife and I got it, and we tried it. And like it took us about a week we hit the chocolate strawberry first, then we did the chocolate cherry. And it's so good. And so we went back to Target like a week later before the bag was gone, and they were off the shelves, and they're not online, and they've never been available ever fucking again. This was like 10 years ago. It was chocolate cherry fucking coffee. It was fucking phenomenal. Chocolate Starbucks on a whim every once in a while does it during Valentine's Day, but it's not every year. We're almost done. Let's finish it off. This is just a number times x, so we're going to divide both sides by that number. I think doing the cursive natural log makes it a little bit easier to read. So we finish off with
Are you dividing 2 times the natural log of 5 or 2 natural log of 5?
wait, what?
The outside, you put the parentheses, the 2 outside of the parentheses and 1.
You're right, I did. I'm like, what the hell are they talking about? I I did these separately in the calculator. When I did it, I got 6.907755279 on top. On bottom, I got 1.139434283. Then when I did the division, that's when I rounded to the thousandths place. So I got 6.062 to the thousandths place. Don't round too early. You round too early, you start introducing errors. And most fields don't do well with errors.
On the exam, you want the decimals? You want the number there?
I'd like to see this. I prefer to see this. That means you actually did it. You just fucking throw everything in the calculator and the calculator do all the work. This is actually an exact answer.
Just, but I forgot to take notes on the thing that is on the corner. Sorry.
You what?
I forgot to take the corner, the notes of the corner.
What corner?
The thousand.
That?
Yeah. There you go. Thank you.
If you're going down the math road, which I think you are, you're definitely going to want to have the exact answer. Because your teachers are going to want exact shit the entire length of the way. Exact isn't really useful if you're going into engineering though, and shit like that, which is what a lot of people are doing. So like 6 point something makes a whole lot more sense. You guys ready for more? Let's kick it up. E to the absolute value of x equals 50. I used a wooden pencil on Friday.
Nice.
I was interviewing adjuncts for the math position, and I had like a stack of pins in front of me. He's like, "You're gonna want to write pencil, so you got to erase. You want to change your answer. You don't want to looking all sloppy on the paperwork." I'm like, "Fine." And he had a bucket of fucking wooden ass pencils, not even mechanical pencils. And then when I grabbed one, I'm like, "Fucking Jimmy." He did. I thought it out loud. I didn't say it out loud, but I saw it. I thought, "Fucking Jimmy."
Dude, mechanical, they're so they break easy. They turn out different. Huh? They don't have to be different. I mean, I've always used fucking wood pencil, not once have I. Ever since, I don't know.
It's just an easy.
Right.
The whole fucking, yeah, but you gotta know. It's just, they're more reliable in my opinion.
That's because just you're used to using shitty mechanical pencils.
Maybe.
A quality mechanical pencil doesn't have that problem. You look like you have it. Is that a mechanical pencil?
Yeah.
Looks like it's one of the more decent ones. I bet you don't. Your tip doesn't break a lot, does it?
Not a lot. It does break though.
On occasion. So does that one.
It does, buddy.
That one gets hella fucking dull really quickly. And then you're looking like a fucking fifth grader or fucking fourth grader. They go like writing with fucking charcoal.
It was nice.
All right, so we don't like having the exponent or the variable up in the exponent. So we want to take a logarithm to get it down. We could choose any logarithm that we want. If we choose base E though, or natural log, what we're going to have is natural log of e to the absolute value of x equals natural log of 50. I will bring the absolute value of x down. And this equals 1. Let's see if we can confirm that for you. ln parentheses, where's my E? Shift E and parentheses. Oh, I gotta say the first power first. Natural log, Shift E to the 1. There we go. 1. Log of 10. Also 1. When the base matches the thing inside, you get a 1. So we're almost done here. Absolute value means if x is greater than 0, it's just x. And if x is less than 0, you do negative x. That's what absolute value of x is. So, like when we get x, we've got 2 answers here. X is either positive natural log of 50 or x equals negative natural log of 50. You get both answers with absolute value, just like a square root sign. And this is approximately, I'll do plus or minus here, 3.912. Can we get done yet? Your pencil dull yet? You need to sharpen it again. You need like a whole basket where you like have like just keep 12 of them sharpened. And you do it at home and you don't look. Are all of them dull? I'm hoping they are. I'm over here not just going like, you know what, fuck it, Eric's here. I'm gonna just use them every day. Even though I got sharpened pencils in here. Eric's my bitch. I'm gonna just use the sharpener.
Yo, I did not say that. You're putting words in my mouth now, man.
You're fucking don't need a sharper pencil and you're fucking putting your hand out just like this every day. I'm not saying it. You're not using the words.
That's not cool, Jimmy.
It's not cool, is it? It's fucked up.
I do that. Yeah, it's not like you. Yeah, I'm not just like, hey, bro, you know. I always, every time I had it, bro, you might play. If he did mine, he would have said no at this point, you know.
You get used to that. He's got children. He's used to the handout.
One day he's gonna be like, "Fuck no, you can't use it." I'm like, all right. Then I'll have to go back.
What?
That 40?
4x. Right. Okay, so first off, what would we do if we had x squared times x to the 5th power? We would add them, we would have x to the 7th, right? Mm-hmm. So we're going to do that here. We're going to add these. We have a different base, we have e now, but it's the exponent rules still work the same. And now, this 5 out front is really fucking things up. 5 is fucking things up. If it wasn't there, we could just match exponents. We've got the same base, the exponents have to match. The 5 there changes that. So we have to take a different approach. This is actually e to the first power. So what we're going to do instead is we're going to divide both sides by e to the first power. What happens when you divide by something? What do you do with the exponents there? You subtract. So this is we're going to have a 5 on the right side. And this is going to be e to the 4x plus x is 5x. And then I've got the -1 from the top. And that e to the 1 is going to be another -1 on the exponent up here. So I'm doing that in 2 steps to show where that's coming from. So we have e to the 5x minus 2 equals 5. I'm the only class you use fucking pencils in, and you have that many fucking pencils in your backpack? And you can't manage to bring one fucking sharpened? They're always unsharpened?
I'm sure that.
You really don't use them for any other class? How do they get dull all the time? Like during break, just ask them, just sharpen them all at once. You won't need to sharpen them ever again this semester.
Probably build themselves up. That.
You know, you get like a sleeve or something that you put them in. It just all comes down to Eric's my bitch. You got fucked up. Jimmy, show fucking respect, man.
Eric, don't listen to me, guy, right? This guy's the asshole.
All right, so we have an exponent. We want to bring it down. We're going to do the same shit we did up here. Base is e, so natural log is a good choice. We're going to take the natural log of both sides. This gets me 5x minus 2 times the natural log of e equals the natural log of 5. So 5x minus 2 equals natural log of 5. I'll add 2 to both sides. I get 5x equals 2 plus the natural log of 5. And when I divide by the 5 to get x by itself, I have 2 plus natural log of 5 over 5. That's the exact answer. In a calculator.
Natural log of e is
It's this one. This ends up being 0.722. Natural log of e equals 1 because it means log base e of e. And anytime these match, the value is 1. So that's what's happening there. And that's why we chose natural logarithm. If I chose log base 10, doesn't equal 1, and then it's going to change the number some. I think Josue's not feeling well.
Probably.
He hasn't spoken much today. Maybe he did come in earlier and heard me talking. He did show up on the list though. How you doing, Josue? Everything all right? You feeling all right?
Yeah, everything is all right. I'm just trying to go ahead because I came late and I'm taking picture and then writing as fast as I can.
Oh, okay.
Sorry, I didn't eat, so I had to go to eat something.
That's okay. I'm just making sure you're all right. You're normally talk more, ask more questions. Tell me you have just one question all the time, and I haven't heard you say that once today. I'm starting to feel a little let down.
You feel sad because I'm not talking.
Yeah. Like something's wrong. That's why I was checking.
Yeah, no, I'm just kidding.
Oh my God. No, this is for the fuck camera. Like the people at home need to see this shit. You don't have to other way to do it. There's, oh my God, there's still more in a fucking zipper thing. So. This is Jimmy's backpack. It's a fucking sickness.
I don't like to have too many because I like you use one and you don't finish it and you still use the other one. That happened to me.
Why so fucking many? Why not just 4? And leave the rest at home and like bring when you need them. No, I can't. Hold on a second. I'm gonna go with this. No, backpack. Like, this is ridiculous.
Also, most of them are gone.
Yeah, they're all gone. I want you over fucking this, the break we take in 10 minutes to sharpen more than one. It's fucking ridiculous. Oh my God, there's like 20 there. Count those sons of bitches. You got more pocket pencils than fingers and toes. There's something wrong, Jimmy.
Yeah, I can't read it.
What we don't know? Jimmy's a fucking Van Helsing. This motherfucker's a vampire hunter. It's like I gotta carry around as many fucking wood stakes as he fucking can. The fuck, Jimmy? Jesus Christ. That's more than the teacher that loaned me a pencil the other day had. He had a bucket. He had a fucking bucket and he still didn't have that many. Jesus. All right.
Why'd you feel the need to take a photo?
Because no one's gonna believe me. And I need to like share it with the other teachers. I won't share your name.
I charge $1 for food.
I'll take a picture of you.
My possession.
Why don't you come try to get that dollar from me then? Let's see what you got, vampire hunter. All right, any ideas? Let's try it. Let's see what happens. Never hurts to try. Always worth trying. Shit. What can we do with that? It's not getting us anywhere, is it? Didn't help. Well, what would have worked if it was positive? Yeah, the minus sign is really throwing things off, as you're going to find. So something, let's bring this back down here. Let me rewrite it. We're going back to what we had. E to the 2x is really e to the x squared. So this is e to the x squared minus 6 e to the x plus 5 equals 0. You know they have electric sharpeners, right? Just real quick, you just fucking zip them through them like go into damn near any office, like main office in this building. I'm at the front office. You're here before
Too lazy.
it's embarrassing. Do you really have do you have like a something you could seal them in if they were all sharpened? With you though?
Yes.
Would you like me to sharpen them for you in the electric pencil sharpener before we leave?
No.
No. Red. Why? Because he wants to treat Eric as what? Well, what if I did something like this? What if I said u equals e to the x? Now this looks like u squared minus 6u plus 5 equals 0. How many times can I circle back before Eric says, you know what, fuck you, Jimmy, quit treating me like that. Swear to God. Well, what can I do here? We could do the quadratic or we could factor. I think factoring is either easier, but if you're going to jump to the quadratic, you should end up also getting the same things. U equals 1 or u equals 5. You know the problem with having so many pencils? I know you can confirm this. The erasers suck. They harden after a while.
No, these haven't, actually. Sorry. Still fine.
How long have you had that bucket of pencils?
It's whole semester.
So just a semester, but not like a previous semester?
Not about most.
Oh, okay, yeah, but if you're gonna still have those in fucking 3 years, because you got so goddamn many pencils, and those erasers are not gonna work, not a single fucking one.
Oh, they're not actually.
They're gonna be fucking hardened to like hardened plastic, and it'll erase, but it'll leave a nice little gray-red smear when you do it. That's why you don't need to buy fucking you know, a gross.
That was actually like a pack of 25, I think.
What happened?
Or 30.
Nothing happened. All right, so we're not done. We didn't start with you, so we're not gonna end with you. We're gonna go back to E.
Substitute here.
E to the x equals 1 or e to the x equals 5. One of these is solvable without taking the natural log of both sides. But it still works for both on all of them. Take the natural log of both sides. I didn't give myself a lot of room to write it there. And we're going to bring the exponent down. Is that a fucking wooden spoon? What the fuck?
So where's that spoon?
Is there a fucking chef program here or something? Why do you have a big ass spoon?
It's a regular size spoon.
It's a what?
It's a regular size spoon. What do you mean? You got a spoon, it's regular.
Sure it is.
It's one of my friends works at Yogurtland. She gave me a spoon this morning.
And that's the spoons they have at Yogurtland?
Yeah.
Holy fucking shit. All right, natural log of E is 1. What's natural log of 1? No.
Is it just one?
Nope.
I don't know.
Nope.
0.
0. Fucking, it's a good guess. It's right. And I don't know what this is, but it's something. And whatever this is, I don't know. I didn't write it down. It wasn't worth my time. Let's take a 5-minute break. And then we'll do logarithmic equations rather than exponential equations. And then we'll finish off with like some 4.6, like some exponential decaying growth. Unless no one needs a break, I can keep going.
Are we gonna finish early? We keep going?
5 minutes early.
Yeah. Let's do it.
Just keep going. All right, we're gonna keep going. I think if you're gonna be able to hold me to that, you're gonna be like, motherfucker, it says fucked up. You're done.
I'm a good. You're supposed to
Who starts packing his shit? All right. 4 natural log of x equals 36. What? And he's gonna take a bucket break anyways. Look at this motherfucker.
He's using that as an excuse.
Right? We're gonna divide by 4 first. Now, how we bust shit out of a natural log or a logarithm is, I'm gonna rewrite this as log base e real quick. Because this next step holds regardless. Whatever this base is, treat each side as an exponent to that base, to the log's base. So here I'm going to have e, and then up here is natural log of x, and here is e natural log of 9. And that e to the ln of x is really e log base e of x. Just like showing that another way. When that matches that, this just equals the argument. So this whole thing is going to condense down to x. I did not have natural log of 9 over there. I just had a 9. That's what's wrong. So this is x equals e to the 9th power. Which is a really big number.
Do I basically like cancel it out?
Yeah. When you have the base here and you have log base here, these cancel. And it's a property of inverse functions.
So if you have like, say 9 log 9 to the x.
We do raise it to the 9th power, 9 to the, let's look at it. We got a different one coming up. So this is log base 3 of x cubed minus 5 equals 1. what we're gonna do is we're gonna take this and the base is 3. So I'm gonna write this as 3 to the log 3 x cubed minus 5 equals 3 to the first power.
You can do that.
What?
You can do that.
Yep.
Why 3 though? Because it's log base 3? Or
I'm choosing 3 because of the log base 3, yeah.
Okay.
Because this property holds. These cancel out. And I get x cubed minus 5 equals 3 to the first power is just 3.
put any other base as well? Instead of 2?
You can, but it's not going to cancel out, so it's not going to pull the exponent out. So needs to match log space. Did they give you 2 or did you just go crazy? This thing fucking pays out a lot. It's like a special slot machine.
See, I think about
A chocolate brownie.
No, this is
Dark chocolate what? Meanwhile, he's got Snickers and Twix, and he's like,
oh yeah.
I see your fucking healthy chocolate, and here you look like you need a real piece of chocolate. Wow, then he sticks his nose up at your offer. What if, you try to offer something?
I'll stick to the pencil sharpening.
Just no respect.
I'm thinking to be a bad person.
All right, I'm sorry, Jimmy. I apologize. It's all in fun, and if you're not having fun, I will stop for the next hour. I might forget by next Monday, so you may have to remind me that you don't like being picked on, that it hurts your feelings. And if you do, I'll stop again. Every student needs to feel respected and welcome in the class, even Jimmy.
I just have a question. When you do
there it is.
When you do cubic root, that you don't have to add the plus and minus, right?
No, we don't in this case.
Oh, okay.
You only have to do the plus or minus when it's an even root.
Oh, okay.
So the cube root of 8 is just 2.
So you're saying, what if it's not even, like, what if it was a 9 instead of 8?
Then it would, cube root of 9 is not fucking 2.
Oh, I know.
It's an ugly number. It's a decimal number, but it still works.
Leave it as like 3.
I would leave it as cube root of 9. And then if they needed 3 decimal places, I would approximate it to 3 decimal places, like we did with the other problems.
And when you need to check the answers, like when you rise the power to get rid of a square, you have to check it when it is.
You need to check it up here. Go
okay.
all the way to the top. Don't go back here. Go all the way to the top. We got log base 3 of 2 to the 3rd power minus 5. Does that equal 1? So we're doing a check right now. So 2 cubed is 8. Does that equal 1? Log base 3 of 3 does equal 1. The base matches the argument. If you had -2, in fact, this is a good checklist way. If you're like, I don't know if I needed to do the plus or minus or not, try plugging in -2. If you did it, you would have had -2 cubed is -8. -8 minus 5 is -13. And see what your calculator says when you try to do the log of -13. It's going to tell you no.
It's going to tell you no?
Well, it's going to say syntax error or something like that. You can't take the logarithm of a negative number.
Okay. No, but like my question was like it was when you write like to get rid of a square root or a cubic root or whatever, um, you have to check it or you don't have to check it when it is even or odd. I don't remember which one you have and which one not. I forgot.
That's when we're working with radicals.
Yeah.
We're not, we, this is something different. That's something completely different. That's when you start off with radical equations, and we didn't. We started off with a logarithmic equation.
Okay, so here we need to check it or we don't have to.
No, not unless you do something wrong.
Oh, okay.
I just showed you the check, show you that it works. That's why log doesn't generate. Square roots of negatives generate imaginary numbers. Trying to do a log of a negative, it doesn't work. And the reason why logs of negatives don't work is real quickly. This is y equals e to the x, crosses at 0, 1. And this is y equals natural log of x, where I use the same base, or log base e. There's no negative values. They are inverses of each other. They are reflections of each other across the y equals x line.
Isn't E just log? Or is E just a natural?
ln is natural log and it means log e. E is like 2.71.
What's the number?
It's a number. E is a number. And you can see what the number is by, if you want to know what does E equal? Put e to the first power in your calculator. I only know the first 3 decimal places, so I wanted to get some more. 281828. I wonder if it keeps repeating like that. It looks like a cycle here, doesn't it? So it's a shorthand notation would be 1828 with the repetition bar right there. But log, this graph has no negative x values. X has to be greater than 0. So if you try to take the log, and this is true for any base. I did log base e just to match e to the x, but whatever base you have, they all have this shape. I need to wait a second because I know if I move that page, he's gonna tell me. Now, if you're thinking about when you studied logs before, Josue, the next problem we definitely need to check our work. As you're gonna see.
Let's see.
Did you need that up longer?
Oh no, I'm fine. I'm done.
All right, so we've got log base 10. So log 2x plus 1 plus log x equals log x plus 8. This way, I'm gonna retract what I said earlier. I'm gonna say you should check your work each time on these logs. Because if I say like find a pattern, you may not check it when you need to. But if you check it every time, it doesn't hurt.
So we can have a like a special case here. Like if the answer cannot be like true or there's an answer.
Well, what we're about to do to make this get a solution here is actually going to generate a bad answer, as you're going to see. So what we're going to do is we're going to use, I have logs here. I can't raise these to the power of 10 because it makes it like ugly. Well, can I? Yeah, actually I can. And just raise the whole thing to the power of 10. Raise that to the power of 10. So I have 10 to the log 2x plus 1 plus log x equals 10 to the log x plus 8. So you should check your answer every time. Because this is the exact same thing we did in the last problem and it didn't work. It doesn't work here. I can separate this into log 2x plus 1 times 10 log x. And that's kind of what we need to do to proceed. You don't want to have any plus signs between logs up there. So each of these has an invisible base 10, and the 10 log 10 cancels out, and we just have the exponents. And this is multiplied by that. So we have 2x plus 1 times x, and on the right side, we have x plus 8. So I'm going to distribute here. And I'm going to subtract this stuff over. So we have 2x squared plus x minus 8 equals 0. So 2x squared minus 8 equals 0. If I divide by 2, I get, divide both sides by 2, I get x squared minus 4 equals 0. And when I take the square root here, I get plus or minus 2. Check these in the initial equation. If I check x equals 2, I've got log of 2 times 2 plus 1 plus log of 2. Does that equal log of 2 plus 8? The rules are going to let us put this is 5. Log 5 plus log 2 equals log 10, which is 1. You can actually verify that in a calculator using properties of logs. Multiplication on the inside is addition on the outside. This is the same thing as log 5 times 2. So if I didn't say log 10 equals 1, you'll see that we get log 10 equals log 10. So that worked. And everything was peachy keen the whole way. We check x equals -2 though. I have log of 2 times -2 plus 1 plus log of -2 equals log of -2 plus 8. This gets us log of -3. And this is log of -2 equals log of 6. The problem is, if I multiply them together, I'm going to get a 6. But neither of these works. X has to be, the argument has to be greater than 0. And those are not greater than 0. So X cannot equal -2. This violates the domain of log. Now, one way you can deal with this is deal with it early. I'll wait a second. We don't want it to violate any of the logs. So what you can just do is like find the domain early. In fact, I'm going to do it. Let's do it on the next problem rather than redoing this. I'm going to do log base 2 of 2x minus 5 plus log base 2 of x minus 3 equals 3. This needs to be greater than 0. And this needs to be greater than 0. So just find out what they are. 2x minus 5 has to be greater than 0. So 2x has to be greater than 5. X has to be greater than 5 halves. Here I have x minus 3 has to be greater than or 0. So x has to be greater than 3. 5 halves is the 2.5. So if I want to meet both domain restrictions, got to meet both. One of them says do this, one of them says do this. We have to do the one that has the area that has both. So this is the overall domain restriction. X has to be greater than 3. So if we find a number later on that is less than 3, we're going to kick it out right away. Or you go through and you do the solution normally, and then you plug them in and see what works. But you very much have to plug into the initial equation, whatever you start with, without any single fucking edits. All right, so if we do this one, we can put this together. This is easier to put together now, because multiplication on the inside of a log equals addition on the outside of a log. So I can put them together now. It's probably the easiest way to go about doing this. really thinking about getting the MetaQuest 2. It's on sale for $250. You get $50 for their thing, and then 50. I could buy Vader Immortal, and I could fight Lord Vader. Pretty fucking badass.
Ooh,
And then there's also Iron Man, and I could fucking play Iron Man.
that's actually.
But fighting Vader wasn't cool? Get the fuck out.
But
This is why I pick on you. You say some stupid shit like that.
the Iron Man is not awesome.
Iron Man is awesome, but you kind of like smeared at Lord Vader, fighting Lord Vader. Fighting Lord Vader? That's fucking badass. You go through like a lightsaber training academy, and then he fucking, I assume he shows up and like tries to fuck shit up, and so you fight him. Now, me, I would rather just like kneel to him and say, "Oh, hell, Lord Vader, can I be your Sith bitch?" I'll be Vader's Sith bitch. I don't want to be fucking a Sith Lord. You're making fun of it. But if you watch Star Wars, all Luke Skywalker does, and the good guys do, is use some telekinesis to throw shit around, use the Force to move shit. The bad guys do that, and they fucking shoot lightning out of their hands. So why settle for just the pushing shit around when I could fucking keep my phone charged with a little bit of a zzz? You know what I mean?
Really got into Star Wars then. So
We all have our faults. You more than one.
let's say it's not a fault.
You would say that.
Oh fuck, Jimmy. No.
That's right. The fuck, Jimmy.
It is what it is.
How do I go from here? Where do I go from here?
6 times 5 times 26. Like more, like
I can multiply those out. Yes, let's multiply those out. That's what you're saying, right?
Mm-hmm.
I got minus 5x and minus 6x is minus 11x. That's helpful. Wasn't the step I was going to do, but we're going to have to do that eventually. So it's worth getting her done. Now what?
we make it base of 2.
Like do this, raise each side.
Raise each side.
Say what?
Raise each side of 2.
Yeah, like this. So we end up getting 2x squared minus 11x plus 15 equals 2 cubed, which is 8. That's very valid. That's a good strategy. I like that. I will subtract the 8 over. And so I get 2x squared minus 11x plus 7. Luis, factor that for me. If you can't figure out how to factor it in 1 minute, go to the quadratic. Don't waste a lot of time trying to factor something. If you could get it to factor it, you're going to see that x equals 11 plus or minus the square root of 65 over 4. Which means x equals 11 plus square root of 65 over 4. Or x equals 11 minus square root of 65 over 4. Now, square root of 64 is 8. So square root of 65 is a little bit higher than 8. Like 8.1 or something. You laugh, but this is a great way of estimating shit. I don't need to get out a calculator because here I go like this is like about 11.81 over 4 19, even if I just get down to 8, 11 plus 8 over 4, 19 over 4, let's just do the 8. 19 over 4 is greater than 3. So this one works. If I do that here, 11 minus a little bit higher than 8, I'm going to get 3 over 4, and that is less than 3. So that one's out. The actual retail value of this is approximately 4.766. I used the quadratic formula and I didn't write it out all the steps. I just sped it up. Good.
Wait.
I felt it. I was stopping. Hold the pace. I'm ready.
Time's on.
You good too? So this is where the equation starts. So this is where we'll have to check our work. I'm going to do that base 3 right away. And I get 4x plus 1 times x plus 1 equals 3 to the third power. Four x squared plus 5x plus 1 equals 27. So 4x squared plus 5x minus 26 equals 0. This does factor, but you probably would get it quicker if you just did it quadratic, because this factors to 4x plus 13 and x minus 2. And picking 13 and 2 isn't all that intuitive. So I get x equals negative 13 over 4, or x equals 2. I'm hunting vampires. Look at Jimmy. We check our work. X equals 2. I got log of 3. 4 times 2 plus 1 times 2 plus 1. So log of 3 is 9 times 3, or 27. On the right side, I need to equal 3, and it does. The big idea here is this is positive. So it works. It didn't create a violation. What if I stick in negative 13 over 4? I'm missing a +1 there. +1. And then 13 over 4 +1. So this ends up being, I got log base 3. This is -13 +1. And let's write this as a decimal, -3.25 +1. I got log of 3 -12 times -2.25. There we go. What is -12 times -2.5? Did I do not 2.5, 2.25. $27. Which is what we had above. So here, both answers work. Both work. Because they both work in the initial equation. If we had started with log 3 of 4x plus 1 plus log 3 of x plus 1 equals 3, then x equals -13 over 4 wouldn't work. It's all about the way the problem comes. And our rules of logarithms say that these two are equivalent. But the rules of logarithms only apply if each individual thing is greater than 0. All right, so that's 4.5. Let's take a look at 4.6. I'm going to do some stuff briefly here. Did you need that up longer, Josue?
No, I'm fine, thank you.
All right, this is the good shit. 4.6 is exponential growth and decay. This is why we have shit like this. Applications. Exponential growth and decay. This is like a population model. And exponential decay is like radioactive decay or carbon dating. Polonium dating or whatever the hell it is. The basic setup for this is y equals y naught times e to the kt. Y naught is the amount present at time t equals 0. So t is time, y naught is the initial value. And K is where all the magic happens. K is the growth or decay constant. K greater than 0 is growth. K less than 0 is decay. How do they do this in the real world? We have a little table. This is going to be carbon dioxide. And ppm is parts per million. In 1990, 353. In the year 2000, 375. And then we're going to start just like making up future years. We can go back further, but they didn't monitor carbon far enough back to make it useful. So we don't know what the decay or growth constant is. It looks like the carbon dioxide is growing over time. Let's set the year 2000 as our t equals 0 year. So like if I do 2175, t equals, what would t equal if 2000 is 0?
75.
It'd be 175, because this is time in years. So that's how we're going to take advantage of this. So if this is t equals 0, that makes this y0. And when t equals 175, this is just y. So I've got y equals y naught e to the kt. 1090 equals 375. E to the k times t is 175. So I'm pulling information from those 2 years. If I chose different years, the k is probably going to be a little bit different, but it should be about the same no matter which year I choose. Is everyone with me on the setup here? I said this is going to be our starting year. So 2175 is 175 years later. And this would be my y naught. Y is whatever the current value is. So if I plug in like t equals 0, I got y equals 375 times e to the 0. I get y is the same value here. If I fast forward 175 years, I never found out what k was using this, but if I go forward, I know what the future amount should be. Should be 1090. I started with 375. I've done 175 years. I can use this to find K. So let's find K from this. So I'm going to start off, I'm going to divide both sides by that 375. I want to get the E to it, E by itself. Then we take the natural log of both sides. Oops. There's an equal there. This gives me natural log of 1090 over 375 equals, I can bring the 175K down times the natural log of E. And natural log of E is just 1. That's just 1. So I can divide both sides by the 175 and I'll get K. K equals, I'm going to put this out front, 1 over 175, natural log of 1090 over 375. It's likely a small number. I am getting K equals, well, my calculator says 6.097182567 times 10 to the negative 3, which is 0.006097182567. So the carbon dioxide model will follow y equals y naught 0 or e to the 0.006097182567 T. I wrote all the decimal places because I don't know if they matter or not. So like the pre-industrial era apparently had carbon at 280 ppm. When will it be triple that? So I don't know what triple that is. I'm just gonna actually just write it as 3 times 280. Why not? Is back to what we had before. It was the 375 from our year 2000. I should have had that. I relied on that being the starting year. So what is that, 840? Divide both sides by the 375. This is probably easier to leave K in until you actually need K. So we'll take the natural log of both sides. All right, writing that. I'm going to put KT. So T equals 1 over K times the natural log of 840 over 375. Natural log of answer divided by 0.006097182,567. I'm getting T equals 132.27 years. T0 was the year 2000. So this means this is the year 2132. Y equals Y naught, the KT is also for continuously compounded interest. I'm going to show, I'm not going to do a full problem. I'm going to get you started because Luis is going to hold me to that 5 minutes early bullshit, which is in 3 minutes. So like, how long for money to double? At continuously compounded, if K is our interest rate, K is 0.06 or 6% interest. Where Y naught is your starting value, your principal. I'm not going to say what we start with because guess what? It doesn't fucking matter. If I started with 1,000 or 10,000, the same thing is going to happen. If I want, how long does it take to double? How much will I have left after that time if I double Y naught? What should be my value if I double it? Double Y naught, 2 Y naught. So it could be 10,000 and 20,000 or you know, $1 and $2. Oh, no banks are going to give you fucking interest on. Let's get realistic. But the idea holds the same. The initial investment doesn't set the doubling time because the equation gets down to 2 equals e to the 0.06t. We'll take the natural log of both sides. Where on the right side, I already just pulled it down. And I get t equals the natural log of 2 over 0.06. You're going to find the doubling time is always this. T equals ln of 2 over k. Guess what the tripling time is? What would change in that equation?
3, why not?
We'd have a 3 rather than 2, why not? We'd have 3, why not? So when we take the natural log, we'd have a natural log of 3. T would equal the natural log of 3 over k. And this works for any of these formulas. When we go to decay, I'm going to finish this in under 60 seconds. Half-life is a decay formula. The same principle holds. We're not looking for doubling time anymore. We're going to have t equals natural log of 1/2 over k. K will end up being less than 0. And they won't start you with that. You'll probably like say, do you really want to leave 5 minutes early? You want to see like a quick decay problem? All right, we said fuck it, but I'm going to keep going for everybody else. So like, let's say we have 800 grams and 2.5 years later, 400 grams remain. So this is radioactive decay. This is how they do carbon dating and shit like that. To find what we have 400 grams is our N value, equals 800 grams times e to the 2.5, that's our time, times k. I can put the units in there because when I divide by 800 grams, the units go away. And I get 1/2 on the left equals e to the 2.5k. Take the natural log of both sides. And I get 2.5k natural log of e equals natural log of 1/2. So k equals natural log of 1/2 over 2.5. And we could use that to see when, or like maybe we want this to be below a certain amount. Like how long will it be where it's like, when will it be less than 1 gram? Well, 400 grams is the most current amount. I'm going to start with y naught equals 400 grams because we're going to go forward from here. I want Y to equal 1 gram. And I have K there. So 1 equals 400 e to the K T, where that's K. I'm going to leave it as is for now. We divide both sides by 400. I get 1 over 400 equals e to the KT. We do the natural log of both sides. I know I'm going kind of quick. Time constraints here. K is a number. We still have K here. So T equals 1 over K times natural log of 1 over 400. T equals 1 over negative 0.277 25872. Natural log of 1 over 400. Did that wrong. Two seven seven 5872. T equals 21.58 years. It seems kind of low, but it was cutting in half every 2.5 years. So in another 2.5 years, it should be down to 200. 5 years, it should be down to 100. 10 years, it should be down to 25. Yeah, it's cutting in half pretty quickly. Should be down to less than a gram in 21 years. That's how they do radioactive decay. That's how they can determine how long it's going to take for Chernobyl to be safe, by knowing how much radioactive material they started with. This is how they do carbon dating. They know the decay time of carbon. And so they check to see, like, when something's sealed away, what's the carbon levels at now? Like organic material has a certain amount of carbon in it. Living organisms were carbon-based life form. Carbon decays upon death. It doesn't start decaying until you die. Because we keep replenishing with what we eat and breathe. But like when you die, it starts decaying, so they can go, all right, we see how much carbon is left. We can tell how long ago it should have been the full amount. So they go work backwards.
Basically, so when they die.
Yeah. So like you find a fossil, you find remains, you can check the carbon level and go, this has got really low carbon for what it is. This thing must have died, 30,000 years ago or something like that, 100,000 years ago. That's what they use this for. Have a happy Thanksgiving.
Happy Thanksgiving.
I assume everybody celebrates some form of Thanksgiving. It's not a religious holiday. It's a chance to eat food. Make sure you don't get comatose. Enjoy your football game. Who are the Cowboys playing? Who are the Lions playing?
I don't know.
You don't know? You don't not know. You guys are football fans. What the fuck is wrong? You don't watch football on fucking Thanksgiving? I even watch football on Thanksgiving.
We play on Thanksgiving too.
Who are you playing then? The Lions?
Dude.
Cowboys and Lions always play. Does anybody else play ever?
This Thursday.
So you're playing one of those two teams.
From Seattle.
Do they have more teams playing on fucking Thanksgiving than the Cowboys and the Lions? When did that change?
Have a good day.
The year before, somewhere around.
That's some bullshit.
I was like, that's all.
Have a good day.
I was watching the Eagles and Chiefs right now because I just want the Eagles to lose. Yeah.